I intend to show, this is red laser light, and I intend to show that as that reaches our accelerator, it becomes stretched because it's accelerating. It is light, it's accelerating. They say that's not possible. I also say that is the particle, and that is the particles invading each other's region, turning into plasma, going through the venturi, creating the interference patterns, they say, not interference patterns, sprayed away because of magnetic repulsion. I also say these little white dots are the ether. And I also say that the extreme reverse magnetic field reaction here accounts for the way light literally works. And I show all of these things in the experiments. I show actually the particles of light. I show them that they are dipoles and they are likely toruses. Stay tuned. It's Roger, Mud Fossil University, and today we're going to be talking about the hunt for ether. They have accepted it now. The scientists say, well, yep, well, finally we've changed our mind. There is ether. However, I believe they're trying to obfuscate the whole issue and trying to make something out of it that it isn't. It is nothing more than sunlight and the particles in space that are thrown out by luminous bodies. I will prove this to you right now. You should watch this video. It's fabulous. You might want to watch this video right away. 2019-2020, put out yesterday by, well, today's the 29th. Anonymous official put it out yesterday, the 28th. Very good. And this is the kind of stuff that we are actually doing, the same stuff, only we're using electrons. They're using protons, heavy particles. However, I think if my research is correct and the venturi is correct, it could be used to make plasma with heavy particles, not just the plasma like we're making with electrons. All right, CERN hit head-on particles, just like two coming head-on this way. What we did was we crushed our particles together. Same end result. You saw that wave. We forced the particles in that wave, and that's all the bits that are in that wave are these tiny little particles. And the reason those particles make such a huge ripple as they come through space is because that particle, now as it exhibits glowing, the reason it glows is because it owns a region around itself much, much, much bigger than what you see here as the glow. That region, when it impacts with another region, it glows, and the other region glows. So they begin to stack up on their own selves as they reach the venturi, which is right over here. Now, in that venturi, they are crushed into each other's regions. They have fields around them. The particle is almost nothing. You never see the particle. That's why it says nothing there. Well, of course there's something there. The particle is there. It's unseen until it's crushed. The harder you crush it, the harder the brighter it glows. This is Cherenkov radiation. This is literally above white. It's a glowy white frequency that is created in Cherenkov, highly accelerated particles. As it leaves the venturi, which is two round pins. There's two round pins like this. And we force that light to force itself through just like airplane wings. And it accelerates just like it does through the nozzle of a hose. It comes out here in this spray of highly excited electrons. Because I say light is an electron. Now, as they come out of here, all being negative, having a negative propensity, they want to get away from each other as fast as they can. The main stuff comes straight through the center, and that is what every bar here sets up a region of positive and negativity in the air. So that's what creates these stripes. The last bits are not corralled in by another layer of negativity, so they're able to spray into the atmosphere is the way they would like. Now, when these come through here at this highly accelerated speed, we get the same effects that CERN does. Same thing. I'm going to show you what we get. Only we have something. They should be able to look at our stuff and say, this is the reason this happened. I can't tell you why. I could show you a particle that is smaller than light. All right, that's my statement. It's smaller than a particle of light. Now, what you see here is the Cherenkov radiation that I spoke about, the highly excited particles coming through that venturi, crushed into each other's regions, want to get away from each other. They spin out of here in these little filaments to try to explode away from each other. And what happens is as soon as they begin to slow down, because they are accelerated now, at a certain distance from the accelerator, they explode into a magnetic field which surrounds this particle, which is it's a charged particle, means it has a negative charge. As it smashes into the ether, which we are talking about, all the extra negative particles that are in the air, they polarize surrounding that particular charged particle. They create a field around it, exactly like they would electricity flowing through a wire. Except this is the particle. And then these fields follow them. So the particle goes, the field is with it. It just can just like this, and they go every different direction. Now, you can see the tiny little ether particles polarizing surrounding the central core. It's not very difficult to see what's going on there. Now, this one here, I believe, is spinning backwards. There's a right-hand rule in nature. Anything that spins against that is going to heat up and gather its energy into itself. That's what that's doing. The other ones slip away. On the right-hand rule, they slip. The left-hand rule, they gather. Now, this is what I want CERN to look at. What is this? What's that? They all came out like this, except that white particle, which is this. They all came from red laser. They all came through the accelerator the same way, except this one. That one came out glowing, I believe, gathering its energy into itself, and at this point it's impacting with another Higgs field or polar field, whatever you want to call it, surrounding that central particle, which we do not see. And as this impacts with the field generated by that tiny little particle, it seems to be creating its own field and giving off a portion of a field. Now, this to me is what CERN is doing in their head-to-head collisions. We are creating the same sort of effects by crushing. That's all they're doing. Once you hit something with another thing, you just crush it. If I took a car and I pushed it against a wall, I crush it. If I put it, you crush things, you crush them. That's all. And that's what I'm doing here. And that's all they're doing. They're sending one proton this way and one this way, smash. Well, we're sending one this way and smashing into this one. Same thing. What are they seeing? If they did the same kind of experiments we're doing, they could see these kind of results, which we're seeing. I don't know how to interpret this. Maybe they do. They say, oh, we map all this, we see this, we understand that. Well, I can tell you what. If you did these experiments, then you should be able to tell me what's going on here, because this is light. These are the particles you people work with. What are you seeing? What am I seeing? This is what I'd like to have some help with. And I have not one single response from any, except for the University of Geneva, where I took a course, and they said, well, boy, that Venturi sure looks like magic, and that was the end of that. I finally dropped the course. It was nonsense, to be honest with you. So this is what needs to be looked at. I don't see why this should be ignored. So I know I have a little bit of an attitude, but why is all of that stuff valid and this stuff is not valid? This is light. These are pictures, and I have actual particles. I'll show you the particle. All right, I'm going to probably leave it at this, but this is coming out of the accelerator, and as they do and crash into space, they stop basically. Not stop, but they exhibit for 2 cycles, and then they start to settle down. And this is what we see. And that black and white means you have power and no power. And if you can look at that, you can see that there's these little spikes coming up from here and here. Now, how could that possibly be? That, I say, is a torus. And there's a neck in the torus which creates inductance. The torus itself creates capacitance, a capacitive area. The inductance is the neck, and that is the venturi, just like I showed our venturi creating that extremely white energized light, and this is it. And it's the right hand rule. It spins up here to the right and right down, and then it's complete backwards field, still spinning to the right, comes around, starts to accelerate again, spins to the right, down in, it's glowing, still to the right, push backwards, now creating darkness because it's gathering, and it just continues around. And it will sit there and not do anything at all unless somebody bashes into it. Then it will start to glow. And as they sit in a mass, they will sort of jiggle and glow and stay warm. And every now and then another electron will push around in there, and they'll all sort of jiggle and heat up and glow. And if it gets cold, all those electrons leave, and they see there's plenty of room for it. So, I can relax now. That's what heat's. That's what cold is. That's what light is. That's what electricity is. Static. Ether. Okay, I decided I'm not going to let you off this easy. What you're going to have to do is understand that the nucleus is nothing like it's being described. The nucleus is electron flooded. What that means, and I'm going to show it with this toy, this is incredible tractor beam magnet. Latham's crazy machines. He is literally constructing a nuclear core right now, flooding negatives against a huge positive attractive force, which will create a zone of attraction, which is quantum. Now let me just turn this down so you don't hear this. Now, here, boom, see? Now watch, he's going to put this in a negative relationship, well, in an opposite relationship to the negative electrons. And now he is going to introduce another electron, and there you have quantum mechanics demonstrated. It will stay in that orientation between the attractive electrons of the core, and it may float around here because the core may drift around in a normal circumstance. Here it's locked into this brass ring. However, in a normal nucleus, it may float around like this, and these will all jiggle around, but they will be in an exact circular pattern surrounding the core. And we know, well, I don't know if it's a fact, but it seems to work out, the S1 orbitals, and then you go into the second orbitals, and then you start into the rule of 8. And I can show this. I might as well show it to you now. Like I said, I'm not going to let you off the hook. It's going to take a while. It's time to straighten this thing out. Now, as I will demonstrate later, and he is demonstrating right now, as he shakes that, that will be heat, which will be more electrons are forcing their way in, or there's some kind of banging motion going on. As he excites that so much, it will leave its orbital, and it will float into space, exactly what sunlight does, identical. Here we get a little piece of sunlight, and that right there, my friends, boom, 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 there it goes. Sunlight. All or nothing. So we're going to go into the nuclear core, we're going to go into the electron flood theory. And I say there are no neutrons. None. Zero. Never had them. They're just a nonsense thing. They would roll away from the positives or the negatives. There's just nothing. And then they decide, oh, and then they turn into protons and they decay into this and that. It doesn't make any sense. Now, what is really happening is that in the core, it is flooded with electrons. All the positives, instead of neutrons just hanging around, rolling around in there, the electrons flood the positiveness of the core until it exceeds the positiveness of the core, which I showed you in that little quantum toy bar magnet thing. I mean, tractor beam magnets. What does it do? The core then is electron flooded. So what do you got? Positives and negatives. What do you end up with? You end up with a ball of bar magnets. It's a little round ball full of bar magnets. And they end up only being stable at an exact resonance frequency. Overall field of the core determines the resonance frequency. And there's 8 very solid resonance frequencies. And those are the Fraunhofer lines. There's a 9th, I believe it pertains to the S1 orbital. But the rule of 8 pertains to the valence orbitals. And they show up very nicely in resonance frequency experiments. I'm going to show you that. So, and I will show them lock in at those frequencies and be unstable at the frequencies where they are not stable. They will be unstable. That means that those are the isotope regions where they are not in the just standard center style. Yeah, that's stable. That sucker's never going to fall apart because it has the noble number of electrons, 8 in the valence. So we're going to look at that. So isotopes are the unstable ones. They're due to the rule of 8 stability. They don't have 8 in their resonance frequencies. So what are we talking about resonance frequencies? It's the distance of the wave that shakes back and forth between the core and the orbitals. And the red orbitals are they very long frequencies, so very low voltage. So what you're going to have is a low attractiveness. And they will pop away easily, and they will be the outer electrons in bigger. Well, actually, the electrons in the red regions and so forth, and all of these colors come from transition metals. There's a whole another story about that. It gets a little complicated. I'm not saying it's all simple, but the colors appear to come from transition metals, which there's 100 transition metals, so there's a lot of colors. Now, that is the nature of an atom, of an element, of a core, of the magnetism that affects the core. We saw in that little tractor beam magnet. It's the only thing that makes sense, and it's the only way the Fraunhofer lines could possibly create the same exact frequency resonance on absorption and emission. I thought of every single, I can't think of everything, but, I really tried hard to think of any other way, and the only way is that the attractiveness of the core determines the emission of the electron and the receiving of the electron, because that's nothing more. It's going to spit one out or it's going to suck one back in. And if it's a one way out on the outer orbitals and it's not getting excited too much, it pops out a red one. If it's really getting banging around and it pops out a heavy duty one, one of the ones that are more tightly held. So this is all it is. And it determines how tightly held it is. It's held at 1.2 volts. All right, if we hit 1.2 volts, let it go. All right, bang, it left. That means it's blue. If it's coming in, it says, well, if you're going to smash into me, what voltage do I need to accept you? Well, I need 1.2 volts because that's the one where it pushes the electron into the core or drives it out. I really don't have a certainty for that one. But it'll be able to be figured out because it's the only thing that makes sense. So let's go past this. No neutrons. All right, I am going to finish it up now. I don't have much more to go on this. This is what I'm thinking in the electron range, and this is what I'm thinking is happening more of these little bar magnets all coming together. They actually turn into crystals. When you see what the electron looks like, it's got a glow and a not glow and a glow and a not glow, and we saw that. So I'm trying to figure it out now, but we'll get there. All right, Mud Fossil University. All right, I'm going to try to make this as simple as possible because it can get very, very confusing very quickly because there's a lot of variables going on here. First of all, let me just tell you, the Earth is a positive suction source for electrons, and everything has electrons. All light is electrons. So that's going to be sucked to Earth. And we know the light comes down, slams hard into you. You get sunburn and everything else. It creates electricity in solar cells and so forth. Now, so we know those electrons are being sucked to this positive Earth. We also know that they accumulate more densely closest to the attractive positive source. And we know that all electricity will try to get to ground. And we also know that an atomic bomb goes straight up off the surface of the Earth. And I'm going to explain that in a second. Now, when I talk about the variations and variabilities, this Earth is spinning as it is ripped through the galaxy on the arm of the galaxy. So it's not only being ripped through space, it's spinning at the same time. And space is loaded with electrons, which are nothing more than light. So the magnetic stripes that are in the Earth's oceans, as it spins, they're magnetic stripes, nothing more than a commutator of a motor. And as it spins in the magnetic particle field that surrounds it, it creates electricity and it creates a field. It's exactly what we have, is a motor ripping through space. Homemade atomic bomb. All they do is take dense matter. It's plutonium and all that business where the electrons and the nuclear stuff is so tight together that it just hates it to be that way. Now, I showed you in the Venturi, everything exploded when it hit together. Well, this is like an exploded already just sitting there. It wants to fall apart. That's why it's dangerous, because it's falling apart. It's sending out bar magnets, chunks of bar magnets, not just electrons. So this matter here, what happens is it's in like a tube where they jack it off the end so hard that it can't go anywhere. They put a couple of bombs in the middle. They push this together. When it coalesces, the electrons are the weak part, and they go, you get that gigantic flash. Then you have a positive core, and the positive core does not like the positive Earth. Let's go see about that. Okay, this is by Guide Wiki, and it's an atomic bomb explosion. Now watch what happens. I'll explain it as it goes. First thing that happens, boom, there's all your electrons go, and they are flashing out. Now the second thing that happens is you see these things here. That is the vaporization of the moisture that is in those layers. It vaporizes. H2O turns into, moisture in the air. Now, what's happening here? Here's the Earth. Here's the bomb. Now what's this big huge glow way up here? Why is it down here? Why didn't the whole thing spread out? It didn't do that because it's a positive chunk of material now. All of its electrons have gone, and it now is so positive that the Earth says, get away from me. I'm positive, you're now positive. Normally you're going to have a whole batch of electrons. I'd love to have you come down here, but you get away from me until you can get them back. So it says, all right, I'll take off, I'll go north, and then I'll pull them all back into me. And when they all come back into me in my mushroom cloud, I will sooner or later take on enough electrons back into myself that I become attracted back to the Earth. That is why it goes straight up in the air. There is no other reason possible. And it only happens when you get into nuclear weapons. That's because we've eliminated the electrons, turned it positive, up in the air it goes, and it glows like hell, because that glow is not from a bomb. That glow is from suction. That is from sucking electrons back, not from shooting anything out at this point. So, Mud Fossil University, electron flood theory, there is no neutrons, light can be accelerated, light is a particle, ether surrounds everything, and it is in all matter, it is in all the air. It is in static electricity that is in the air. They are free electrons. Light does not have a speed limit that I can determine. We have accelerated it. We've seen that it actually can be divided. There is a hell of a lot of work to do here in the university systems. Mud Fossil University has already done it. Okay, this is the periodic table. This row here is the row of stability that has 8 electrons in the valence shells, or 2 in the s1 orbital here. Now, so what do you have? You have this matrix going from the core. The first orbital is your s1 orbital, and I say that is the 9th Fraunhofer line. And then you have the 8 other zones of stability, and those are the dark Fraunhofer lines, I believe. Now, this is a guess, but I see this, and I see zones of stability, and I'm going to show you this in resonance frequency experiments with salt. I didn't do them, but I'm going to use that research to just explain to you what's going on. These are the regions. There's a rule of 8 in electronic rule. It's a rule of 8, it's called. And that rule of 8 determines stability. And that's when we have matter that does not fall apart. They have the rule of 8. Once you lose the rule of 8, you are on the margins of falling apart. All right, this is by B.C. Stargazer, stunning resonance experiment with salt vibrations. They're vibrating a metal plate with a tone generator, make a zzz, and they're homing in on exact frequencies, and then you're going to see the rule of 8 kick in. Now, I'll just come right out here and get it where they're starting to shake it. So at 345 hertz, you see that? That right there is the S1 orbital. That is where the electron can exist. Now, we go beyond that out to the next set of frequencies. And see, now we start to take on the rule of 8. You see? 1, 2, 3, 4, 5, 6, 7, 8. There it is. And there's your S1 in the middle. And then it goes up to the next frequency. And they only lock in at these frequencies. Exact frequencies. See, here you have 3, 6, and a 2 or 8. Then it gets more complex, but you're still going to find 8 on every one of these until you get up to the 8th or the 9th pattern. See, here's your 8, 3, 6, and 8. Now, once you hit a certain frequency, it just falls apart. And here's your 8 again, very stable, very strong, solid. In between these frequencies, you're falling apart. All right, here's your 8 again. This one's still going to be okay. There's going to be 8 in here. You can count. Nice, stable, solid pattern. Everything's good here. And then all of a sudden, you're going to get to a point where as soon as it locks in, it falls apart. All right, this one's okay. We got our 8 going on again. Everything's looking good. And then we get up to, this one's still okay. There's our 8 looking real good. Now the next one is where we get killed. See this? Now watch. 4129. Here's our 8. All of a sudden, boom, it just falls apart because we're up in the range where it can no longer continue to hold itself together in that rule of 8. There's too much variation going on. Now watch what happens. It immediately falls apart. See that? No more rule of 8. Go on. Go on. Very inopportune time for the phone, but you can see now we have lost the rule of 8. You have areas that are semi-stable. These are your isotopes. Out in this range, they no longer, they look, some of them are pretty stable, but they're not stable like they are. See these little areas, things are going to be they're going to just sort of fall apart. They don't have that same stability. And that is what I believe happens when you have isotopes. Because when you crush these particles together in nuclear bombs and so forth, you break these nuclear cores and you take out some of the little bar magnets out of there. So now they're right on the edge of being there, but they'll fall apart at some point. So that's that. The 8 strong ones, and then the 9th is the K. And I believe the K is the S1 orbital, the tightest, closest to the nuclear core, and then these are the furthest spreading out from the nuclear core, because this is the distance. Now remember what I said. There's no neutrons. There's no neutrons whatsoever, never was. The core of everything is flooded with electrons until they achieve just a slight bit of negativity in the core. Then it holds the electrons in the orbitals surrounding the core. The nature of the core determines the tightness of the electrons in the orbitals. Speed of light is not set. I showed it was accelerated. I showed they are particles. They concuss, they glow. I showed that they can be turned into plasma in the Venturi, and I think that can be done with heavy particles in a passive Venturi, exactly like I showed, to create plasma, which is all they say they need to create fusion. So I would like to see somebody take a look at this. You put that in some kind of a vacuum chamber and accelerate heavy particles through a Venturi, and they should do the same thing, create plasma. If you have the plasma, then they should reorganize, and you should get 1/5 of the power back. Free. And you don't have to add. Right now they have to use all the electricity in the world for like 1 second to make plasma. Obviously you're not gonna get anywhere. I'm using this as a free. You squirt it through there, it squirts out the other side. Case closed, free. All right, it's time to look into this with a little more respect for somebody else's research, other than it has to be done in a university. Oh, it's got to be peer reviewed. I got to have this. You got to do this. They don't care one bit. In my mind, it's 100% self-preservation. Time to stop this. Ruining the earth at everyone else's expense.